let's go ahead and get, okay, we got to overwrite. All right, let's go ahead and get started. So last class I went through a whole bunch of things. Today, the new topic today is going to be with C++ with overloading, that's function overloading, and operator overloading, which are two separate things. We'll go into that, as well as templates, which are similar to the generics. So today we're actually going to talk about C++ features, which I try and avoid in this class because we're really focusing on data structures, but we got to learn the tool. Luckily, the lab for this is going to be the lab we just assigned last class, the one where you did count negatives and so forth. But instead, you put it inside of a class that is a generic. So hopefully, it won't be that hard of a lab after you do the previous lab. But we need to understand how a bunch of things work inside C++, and it's good to at least take a break or not have such a difficult lab after last class. Hey, look, objectives. Okay. So the idea of a template, and y'all did generics in OOP? Good. So the idea is the same thing. You want to template or generic the function so that you can parameterize the type that the function is operating on. So you can do it with function templates, or you can template a class. I think in Java you can only template the class. Is that right?
I think so.
Okay, so you can template the function. Oh yeah, this is a great question. Why operator overload is needed? Considering the following statements, you create a clock at, first one is 8:23:34, so I'm assuming that's hour, minute, second. And the second one is 4, 5, and 30. On the left, you can print the clock, you can call increment seconds, and then you can ask if my clock equal to time of your clock. On the right-hand side, you could overload ++ so that it increment the seconds, and then you could just overload the double equals to see if the two clocks are equal. So the big question here is, which of the following syntax do you prefer? Look, I'm asking you a subjective question.
The second one.
The second one. Why do you prefer the second one? Oh.
I like the double equals.
Easier to look at? Okay. You like it? What was it?
The double equals.
You like the double equals? Okay.
It's less coding.
Less to type out, yeah, definitely. Definitely. Anyone prefer the one on the other side? You do?
Yeah.
Why do you prefer the one on, I guess, your left?
There's no particular reason. It's just if I were to decode it outright, it probably looks like that. Out of force of habit, I guess.
Okay, so you're used to doing it this way.
Yeah.
Do y'all see any issues with the one on the right?
If someone looks at your code, they might be confused because they're gonna think that the double equals is for
Yeah,
one small one.
without comments, that's kind of vague, maybe.
Oh, what part's vague?
It's not referring, if you didn't know the code, then you don't know what it's sort of referring to,
Okay.
function-wise.
Here's a question. This is my question. ++, what is that incrementing?
My mom, which is the first one.
Well, which of the clock?
Minute or second.
Yeah, how do you know it's hour, minute, or second?
You know.
You don't. Uh-oh. Well, that's why I was like, you're on the right track with vague. So that's where I was going. So you don't really know. Double equals, well, is it exactly the same hour, minute, and second, or is it just has to be the correct hour and minute? What if the clock was taking the nanoseconds? There's almost no chance of the time to be the same, so is it ignoring nanoseconds, or is it go ahead and taking that into account? So it can be a little difficult sometimes when you overload the operator, although the syntax is a lot more shorter, which is nice. Okay, operator overloading extends definition of operator to work with user-defined. All right, that's nice. You can overload a lot of things. You cannot create new operators, so you can't create, some new symbol to mean something else. It has to already be part of the language. Great. Okay. Syntax for this is the operator. All right, guys. I don't do this very often, but it is important. So let's see if we can have some fun. Let's copy the makefiles one. Operator overload. Ding. Probably should give it a -R. Wow, look at all that stuff. We need to. Oh, much better. Now let's just remove everything. Alright, then we'll create our own main. Alright, let's go ahead and include IOStream, int main, int argc, char star argv. I'm gonna close it and reopen it. Okay, there we go. So, what are we doing? Operator formal list. Alright, I really hope they give me a nice example. No, we're going to talk about it more. Okay, how about an example? How about an example? How about an example? We're going to have no examples? Oh my goodness. So they want us to use classes and do the operator. Sure, let's do it that way. Alright, let's create a class. What class do y'all want?
Can it be anything?
Anything, how about that it doesn't go against the CSU Code of Ethics or something like that?
For some reason, robot popped in my head.
Robot.
Alright.
That sounds great. I don't know how we're going to add robots, but that's perfectly fine. So what can a robot do?
Beep.
What's that?
Beep and boop.
Beep and boop. All right. Void beep. Void boop. All right. Now, if you were to add two robots together, what would you get?
Beep boop and boop beep.
I don't know if this example is going to pan out the way I was planning it to. All right. And I always forget the syntax, so const class name blah. All right, sounds great. Const, and we got a robot at, I'll just call it little robot. All right, what's it going to return? Does it say? Joe, just a return type. Well, that's useless. All right. Are we really not going to do any of this? Wow. Okay. So if you're going to add two robots, we'll say you get a robot back, right? Sure, because that makes sense. I wonder if this compiles. Nope. Ooh, our makefile's broken. Let's see, no such file or directory. That's because you didn't add it. Ooh, someone's lying. No such file or directory. Dash wall obj star. Where'd that come from? Ooh, it's broken. I broke it. How'd I do it? Let's see, which one's it coming? Simple source.main. But where is that coming from? Oh. Oh. Because there aren't any. Alright. Robot.cpp. Robot class. Alright, now let's make it. Okay, there we go. Hey, compiled. Alright, so we can add two robots. They probably should have something. What's a robot going to have as a parameter? Or as attributes, I should say.
Name.
A name.
A sound.
A sound, whether it does the beep or the boop, or it does both. How are we going to say that?
Are we gonna give them an option?
Okay.
I'm just gonna put one in.
We'll make it a sound. Okay. And then we'll do make sound. There we go. All right, that is gonna be easy. Good morning. Maybe I should institute the new rule where if you come in late, you gotta give me a good story.
Traffic.
No, I said a good story. You know, like there were puppies in the middle of the road, so you had to stop and take them.
There's a squirrel.
Squirrel?
Yeah.
Yeah, that's just a rat with a long tail that's fluffy.
Pretty much.
Okay. What was I doing? Oh yeah. So I guess the robot will be able to tell you what sound it's gonna make. All right, and I'm gonna go with the Google way of naming these variables, at least the way I was taught in Google. All right. Where I put m in front of the member variables, that way I know which one's a member variable and which one's not. All right, let's see if that compiles. All right. Oh, I know what the problem is. Now let's make it. Good, it recompiled. Ship it. Okay, so we have a robot. So we want to create a robot R. And what sound do we want to give it? The beep or the boop? Nice.
Whatever sound that was.
Oh, okay. What was that? Bun, dum, ba-dum?
Pretty good.
All right. Do you think this will compile? You know, anyone who logged in could hit enter right now and find out. All right, I'll do it. Oh no! Undefined reference to robot. Blah. Oh, by the way, yeah, C++ loves to give you these long explanations. Standard C++ version 11 basic string templated on a character, std character with traits of a character, and the allocator is of a char at the end. Wow. Do you know what that is? This is why C++ annoys me. All this is this thing right here. Notice it's part of the robot : robot. It's saying this right here hasn't been defined. Oh, hey, look, we haven't defined a function. How do we define that function in C++? Have we done that? So the prototype's right up there, but how do we implement it? Do we do implementing this in a separate function yet, or are we just, separate file, or are we, we're still here? Let's do that. All right. So, normally the function, which is right up here, we're going to copy, paste it to try and implement it, and it returns a, oh no, that's a constructor. So it doesn't do anything. Robo. So if you want to define the function later, you can put it down here. Whoever is logged in, please full screen. And then we'll have mSound equals sound. So if I did this correctly from memory, this function right here is the implementation of this one right here. Now let's go see if I did. Yay. Have I done this syntax before or not? I can't remember. All these classes are blurring together. Yes, no. Professor, you look funny. It's 8 a.m. Why are you asking me questions? Come on. Someone alive? All right. So this is the constructor. You can declare the functions up here, like in the header file, which is very common to do, and we'll get to that in a moment. And then you can implement them later on via this syntax. So the robot : is saying that this is part of the robot class, and I'm implementing the robot function, which is this function right here, which is being passed a constant standard string called sound, and then I set sound. So if that's the case, Now, the constructor is unique in that it does not return a type, but if we were to implement another one, say the make sound, you'd have to do void robot : make make underscore sound, and then we'll do std. Ooh, that was bad. What are we calling it? msound \n. Great. Now let's go ahead and tell it to make the sound. r dot make sound.
You put count instead of CO.
Ooh. How about that? Thank you. Oh, we probably should run it. Button to the bum. All right. We're doing great. Now, let's jump back up here. And I skipped a little bit. What is this line of code doing that my cursor is on?
You're declaring a robot, like instantiating. a class.
Instantiating a robot class.
Yeah, and then passing it its sound.
It's sound. Where, okay. So what is R?
It's the name of the robot.
It's the, yeah, the name, or given, okay. Right, so it's a variable name for the robot. Where does it exist in memory? You are right. So that exists on the stack. So remember, Java does not do this. C, you can put classes on the stack. You can make a sound. Hey, let's make another robot. Or, okay, I can't help it. Okay. You know, someone else fill in the sound for R2D2. Hmm?
It's like a scream, right?
Yeah, go ahead. Put it in there. Anyone.
Isn't.
Mm.
It somehow got off my computer that I have in front of me
Hmm.
after the hurricane. I have no idea where it went, but it wasn't there when I searched for it.
Yeah, I know y'all are connected. Someone can type this. Y'all got this. He's been in, how many movies has this guy been in? I guess it's not a guy, it's a robot. The thing, it. All right, that sounds great. Any of the sounds. I know it's 8 a.m. All right. So, no, it's fine. So we'll have R make a sound, and then we'll have R2D2 make a sound. I guess we should have done C3PO. Oh well. Okay, great. And then we'll have, then what is R plus R2D2? Ooh, that's confusing. Is that, oh, actually, is that going to compile? Let's find out. Let's see if this compiles. I have no idea if C++ is going to allow me to do this. Good. Undefined reference to the plus operator. Probably because we defined it up here, but we never implemented it. So robot operator, robot : operator plus, passing in another robot. So we actually need to create another robot. So we'll create robot ret. It will be passed. Let's see. So if we're adding ourself, we'll do msound plus the other robots.msound. And then we'll return it. Okay. Let's see if C++ is okay with that. It is. Great. What did I just do? All right, so I'm overloading the plus operator. Our plus operator is going to return a robot by value. It's part of the robot class. It's operator plus. It's being passed a constant robot reference. Y'all did references in procedural? Oh, good. And what it does is it creates a robot where it concatenates the two sounds and then returns it. So up here, when I add the two and call .make sound, it does the two together. Wow. All right, how are we doing? All right. Let's see. Now, why did I not do this? Is that going to compile? Why not?
Because you're only giving. Hold on. That robot that's made in the plus operator gets deallocated after.
Well, I'm returning it by value, so this robot gets deallocated, but I create a new robot right here when the function returns, and so that robot will exist at this point. Let's see if the compilation error will give us a hint. It did not complain. Wow. It should have complained. Okay, now I'm curious what R3.makeSound is going to do. Oh, actually, okay. So I guess C++, the new versions. By the way, every time I teach this course, I find out that C++ added a new feature. So they apparently have a default equals operator, because in the older days, I guess, you would have to, the problem with this statement is that this guy was not defined, so it would throw an error that I don't know how to set a robot equal to something when I haven't defined the equals operator. But apparently now they just do it automatically for you. That's nice of them. Okay.
Oh, so you would have said like dot equals. And
I would have had to do this. And then implement that function. But now I don't have to. That's nice. Okay. I really don't. Let's see. Okay, so now hopefully you can see we're going to go to the output stream. Basically, you see how you have the double less than sign? That is how C++ makes this syntax work, is they overload what the instructor, operator does inside of the cout object so that it can go ahead and print it out. If you wish to append so that you could have your own class print a certain way to the cout, you can create a friend operator. Similarly to this over here, you would just need to use your constant name out here, because the problem is if I'm down here and I do R2D2, unless they automatically fix this as well. Nope. Wow. Ooh, look at that. Wow. It blows up because it can't see or doesn't understand how do you send a robot object to the less than one. So you do that by implementing this function over here. So we'll go down here and go, let's see, OStream, operator, blah, blah, blah. Wait, this needs to go up here. And I can never remember the syntax. And then constant robot at R. And then we just do okay, and if that worked all the way it was supposed to, almost, ID, probably because it's not called OStream. Wow, it must be morning for me as well. Almost, friend, used outside of class. Oh, we have to make it part of the class. Oh, we don't want it to be public, private, because that would end poorly. guess we return C out. Not gonna like that. Is protected within this context. Did I miss a syntax? Oh yeah, ampersand. Wow. Hey, that was long and confusing. I recommend against doing this. Hopefully you just saw why. But you have to make a friend class with the OStream so that the OStream object can reach in and see the private member variables of your class. It's going to return the OStream. OStream stands for output stream, which by the way cout is because it's an output stream pointing to your terminal. If you're overloading an operator, which one? The double less than sign, which passed the output stream right here, just another way to show it, and a robot object, and then how do we actually call it? And it's by convention you return the output stream at the end. That way you can chain it together when you do multiple of these. Because this one down here with \in, it's actually returning the cout object, returning it down the line, so it doesn't lose the reference to the cout object. Okay, well, that was fun. Same thing with input stream. Great. And there it is for how you do the assignment, although apparently we don't need to anymore. Okay. How are we doing with operator overloads? Should pause here. Do you still like them? Froze.
Be worse.
Could be worse. Could be worse.
Actually, it will get worse.
Oh, it'll get much worse. Okay. Now, by convention, you want to put the header information of a class inside of a header file and the implementation in another one. So, for example, let's go ahead and delete this robot stuff. And source, let me make it a new tab. Tab new source robot.hpp. Boom, right there. Perfect. And then we want to take the code. Well, let's just stick with that for now. And then to include the header file, you do include robot.hpp. And let's just make sure that still compiles. All right. Did y'all see what I did? I just moved it over into a header file. So you can just include the header file, and now you can do with the robot as you wish. Similarly, you want to do the same thing with code. So let's go take this code, save it, and tab new source robot.cpp. We'll paste it, save it, and then if we compile it, is it going to work? Maybe. Does not name a type. Ooh, I wonder what that is.
Definitely doesn't like what you're doing.
No, doesn't name a type. What's the problem with this class? Remember, our makefile is compiling the CPP files individually.
The CPP, the robot CPP doesn't connect to the header.
Correct. The header is not inside of here. So we need to go ahead and include it. All right, let's see if that works. String and name does not name a type. Probably that's inside the header file. Probably because we're using string, but we never included it. I think it's just straight up string. cout is not a member of ST. All right, so then we also need to include IOStream. And there, it finally compiled. All right. It is very common to do this, especially in large projects. Why would we want to do this? Let's see if you all know the answer. Why do we want to do this? Don't think just for this example. Think of when you're working with a large group of people.
You can have one person working on one file at a time, so that way you're not going on top of each other's changes.
Right. Especially when you try and commit them. That way you're not, overriding each other's commits or having to do manual merges or whatnot. It's a very simple way to divide the division of labor. and is very common, and you will see that a lot. All right, so we did the robot. We overloaded some operators. I am not too big into operator overloading. I think I do it a couple of times, and then that's going to be about it. I believe, my personal opinion is it leads into too many problems inside of C++ because you start overloading operators and people don't know what those operators are supposed to mean. People have different definitions, and all of a sudden people are using your code the way you did not intend for them to use it, and then errors ensue and confusion. But it is part of C++, and it is going to pop up here and there, especially since we're using the standard template library. That is basically anything like this is inside the STL, or the standard template library. And so we need to at least understand how it's doing the operator overloading. Okay. Any questions on operator overloading?